Okay, so good afternoon, guys. So I am Joshua Arvin, and I'm the Director for Software Development and Engineering of Beauty L, Deal Grocer, and other sister companies. So for the past 7 or 8 years, I've been working as before I was a software engineer, and then later, when my partners at work resigned, I had to take on the other task. And then later, after that, we had to work with the data scientists, and we had to support the data scientists to be more productive. So we decided to build environments for the data scientists. And then later, we had to work with UX teams. And then there you go. I mean, technology is always changing, and you will realize that as engineers and as professionals, we have to stop thinking about our jobs or our roles. We have to think more about our business, and we have to understand that our titles are just titles. At the end of the day, if we contribute to our business by giving it the intangibles that it needs, then we get to give back and contribute to our to the founders, to the leaders of the companies. All right, so where do I begin? So for today, I'll discuss practical deployment strategies for production Python applications. Last week I went to Santa Rosa, and I had a similar talk, but it was more focused on cloud computing. But for this event, I'll I'll be discussing things more in detail, especially on how we use Python to automate a lot of our work, which was before done manually, and how it helped us be more productive and focus on the important stuff, like customized features and integrations. So it improved our productivity over time. Right. So look at the screen. So you'll see five points there. So we'll start with databases, and then we'll talk about high availability, and then we'll talk a bit about security and how you should modify your Python code, and the way you should think on how to deal with security. And then later we'll talk about management in general. That includes processes. That includes involving your product development team and making sure that they understand the process, and they should understand what their purpose is and how they should work with other people. And then finally, we'll be talking about cost and how to reduce cost. So these things are the things that are usually forgotten by people. And I think that even if you had the best code in the world, even if you had the best developers in the country, if you cannot get the product to launch on time, and if your customers do not love the customer experience, and your site is always down, then your idea is just an idea without it being able to be fully maximized. So being able to deploy it in production is critical, because at some point in your life, your let's say a client or maybe a business owner will ask you, can you do this for me? So for example, a business owner asks you, can you build me an e-commerce site that will allow customers to, let's say, purchase a beauty product, and then later the customer will receive the item. But of course, you'll say, yes, I can do it. But after 2 months or 3 months, you'll realize, oh, the site is always down because the site cannot handle 10,000 customers all at the same time, and we were sleeping, and then the site was down. So, and then nobody was awake at that time. So you're losing the customers, and the chances of that customer going back to the site is lower. So the reason why I am going to talk about this is that we're going to think in reverse. Where do the best practices come from? For example, in security, sometimes you just say, this is the best practice. People don't ask why. So now, let's try to review, and we should reverse the way we think so that we can understand how and why these best practices suddenly became standard. So for example, why shouldn't we put our keys and secrets in our repos? So that's one. And also, what should we be protecting? And what are the things that are usually forgotten when deploying things into production? Alright, so I'll start with a story. So I have been working for 7 to 8 years. Before I was working with PHP, Cake PHP, CodeIgniter, and then after 1 year, 2 years, there came Python, and then I got to use Django with Python. So I was a working student. So it was hard to be a working student, but then at that time I realized that maybe high grades aren't enough to make me to make me a better let's say entrepreneur in the future. Maybe I should have real life experience. I realized that I will only live once, and that I should try to make the most out of my childhood experience. So I decided to work while studying. So I started working when I was second year or third year college, and then I realized that some things aren't mentioned in books, in references, and some of these things can only be learned through real life experiences and mistakes. So experience is very important, and that's why I started working earlier than usual. So what happened next is that life became harder when we were about to graduate. So when we're about to graduate, we of course had to finish our research project, and so that's our thesis, and we had to defend that, we have to design it while working and while also making sure that we don't burn out and we don't get sick. So at that time, we were lucky enough to be part of the Kaspersky IT Security for the Next Generation, and I think that was 5 years ago. And then, luckily, we won that competition. But looking back, I realized that the concepts were still the same. It was a security conference, and we got to meet the other people from different countries. So we got to first see the research projects of people from Asia, and then later, after winning that conference, we got to meet the other winners from other regional conferences, and then finally, so we had the international cup. So we won that, and then I realized that the reason why it probably won is that it was a practical project. It's not the most, or it wasn't the most amazing thing in the world, but the design allowed it to be low cost, and it can easily be integrated to existing websites, like let's say for example Django. And then before, it didn't care about the language. It was portable. So listen to the keywords: portable, low cost, and then it's also easy to fix or maybe upgrade to newer framework. So when you have a standard, you can easily apply it to Rails, Ruby on Rails. So they didn't care about the language. Yeah. Right. So 2 years and actually 5 years, forward, I realized that the concepts were the same. So at work, there are just two things that you need to remember: get things done, and then make sure that you don't waste money. Sometimes you may end up using the coolest tools, coolest frameworks, but end up not releasing anything. And why? So why? Why I can't release anything? Even we're using the latest tools and the buzzwords. That's because we forgot to include in our, let's say, estimates the production setup, or maybe how do you deal with the things that will only happen in production. So, alright, so I'll share a story. For databases, there was a time when we had to manually fix and upgrade our database servers, and we were spending 1 to 2 weeks just trying to fix the databases. What if that the problem never happened and we just spent our time building features? So sometimes you cannot predict everything, but the thing that is only constantly happening are problems, chaos, and some unexpected disruptions. And if you're trying to tell yourself every single time that you're going to launch a project, it's not gonna go down. I think it will survive. Unfortunately, life is not like that. When you are dealing with production systems that host a lot of customers, you'll realize that the world is a chaotic place. Things go down, and you should always prepare for failure so that nothing fails. If you assume that things are going to be fine and something goes wrong and you're not prepared, then you'll lose customers, you lose money. So here, it's important that we have, let's say, database backups, and then we also have strategies when dealing with disasters, so that we won't encounter these failure scenarios and we'll be able to handle them properly. Alright. So why did I discuss database topic first? Alright, so I'll be able to explain that more with this example. Alright, so a couple of months ago, we decided to integrate a new payment method to our site. This is a simple tool. It's a simple website which I built with JavaScript to help developers immediately integrate Stripe to their sites. Doesn't matter if it's Python or Python with Django, Python with Pyramid. This site automates some of the parts without you trying to build the front-end part, so that you can focus more on the back-end. Here, the reason why I share this to you is that, do you think this project is using a database? The answer is no. Why? Because it's just playing around the front-end parts. And the reason why I'm sharing this example to you is that if you don't need a database and if you don't need a back-end server, you don't need to include it in your project. Why? Because the more resources that you include in your project, the higher the cost will be. So that's one. Make sure that you lower the cost. So that's the thing that's always being asked projects, especially the new ones, because sometimes we may end up using a lot of tools and then end up paying for things that we're not really using. Right. Okay. So the database topic is really large. When I say large, or let's say it's, there's a lot of things to be discussed there. There are a lot of databases right now. There are a lot of types. And right now, here you have SQL and no SQL. And in the future, you'll see more of new SQL, and then you'll see more of the different types and the hybrid database servers. The thing that you have to understand is you have to know the CAP theorem. So before choosing the database for your next project, try to know what C means, what A means, and what P means for the CAP theorem. I won't be able to discuss that in detail, but you just have to know that out of the 3 letters, you can choose 2 only. It means that there's a trade-off and you'll use one of those letters. So for example, your boss tells you that the site needs to be up all the time. So A, availability, is required. So you just have to focus on C, consistency, and then P, partition tolerance. So when choosing the right database for that, there are databases that are strong in some areas and then weak in the other parts. And then there are databases designed to handle the other scenarios. So when choosing the right database, you have to choose wisely, because once you choose the database, the libraries that you'll use and the framework that you'll use, let's say Django, for example, you try to force it to work with, let's say, DynamoDB. Maybe, let's say, 2 years ago, it's hard to do that because DynamoDB was new. Maybe DynamoDB was there 5 years, 6 years ago. But then, if you try to use Redis as the primary data store for Django, that's wrong. That's bad. Maybe you can do it, but that's risky. Maybe you should have used something that allows you to do transactions properly. Let's say, oh, you have your super cool big data database. Let's use that as a transactional database. Oh no! And then you'll lose money because that's already a mistake in the planning part. And then you have to migrate it let's say, to Postgres in the future. And that will cost money as well. That will require resources. And migration is not an easy topic. So if you choose the right database, in the beginning, you won't have to worry about migration in the future. So that's critical. The infrastructure side will just um, give you the best setup possible as long as you follow the rules. So one of the advantages of using serverless computing, so for in this example, Lambda, you'll code your Python scripts the same way, except that it's just one function. And when there's an event that triggers that function, something happens. So let's say you call an API function, or maybe crunch some numbers. You can do that inside the Lambda function. So there's an event, there's an input, there's a function, and then there's an output. Here, the advantage here is that when you want to reduce your cost and you don't want to create new servers for it, you just have you may use serverless the serverless setup. Why? So let's say your application runs only 3 seconds per day. So instead of you running having one instance running 24 hours, you can just pay for 3 seconds instead of paying for 24 hours. That's a big difference. It's probably not sure how many percent, but 3 seconds versus 24 hours. There's a lot of savings. And also, if you're inside the free tier, you're not paying for anything. So that's good. And also, this is infinitely scalable because since the function is stateless, you can run those functions all at the same time. And you can also work on projects that require automatic scaling, like let's say ETL, extract transform load. There are times when data, the data that you'll be transferring to some other entity is small. Sometimes it's big. But when you're using, let's say, serverless computing and there's a bunch of mini computers trying to process data all at the same time, you don't have to worry about anything because you just write the code. And if it follows the rules, you can make the most out of serverless computing. Another advantage of using serverless computing is the integration that it offers, the automatic integration that it offers with other services. So it depends on the platform. Serverless computing is a concept not unique to a vendor. So maybe, not sure about the other vendors, but in the future, there will be a lot of these things. Probably there's already some in Microsoft, probably in Google, but the focus of these platforms are probably different. Here, in AWS, you have your monitoring part already integrated with Lambda. So you don't have to worry about it. And let's say you want to store this data, let's say in S3 or DynamoDB, it's much easier. And if you need to secure things when using Lambda, it's already using IAM. So that's one of the advantages of using serverless computing, especially if you're starting out a new idea. But if you try to use serverless computing for everything, you're doing it wrong. You should just use this tool on certain scenarios. Because sometimes it's much cheaper to have one computer running 24 hours. So this part is good. This type of setup is good when you're just running microservices that are only up for, let's say, 5 minutes a day. But when you need a server, when you need an application that needs to be up 24 hours, it might be cheaper. So try to compute things and then try to predict the future because it will have a big impact on how you design the system. Right. So I think that's the last slide, and I would just sum up the entire presentation. So here today we discussed the following topics. So we talked about databases. We talked about choosing the right database and some of the best practices when choosing the database for a project. We also talk about high availability and what are the things that we should be aware of when dealing with unexpected failures and how we should deal with them. And then we also talk about security and how we should think about solving the security issues of our business and our systems. And then finally, we talk about management and then cost. Because sometimes, some production setups allow you or give you the best security or have the highest availability. But in terms of cost, you'll end up paying more. So you just need to balance on what your business needs and how much money you have. So yeah, so that's the end of my presentation. Hope you learned something new.